Hi again. I'm going to try to duplicate the steps in creating this subsurface scattering node using Lightwave Nodal. So I'm going to start with a random normal and average it with a regular normal. Let me start from scratch though. I'm going to go ahead and import these nodes. I've basically loaded an object into Lightwave and I've set up a point light. That's kind of important. And I'm going to activate nodes and start from scratch. Alright, let's see. Let me get rid of everything in here so that we just have our inputs and our outputs, our surface outputs. I'm going to import the average normal and the, let's see, the random normal nodes, which are included in the archive that was on the Lightwave forums. Let's see, that's random normal. I also need import average normal. We could also linear interpolate between two normals, but this is maybe slightly simpler. We don't have to add a third parameter to it. So I'm going to make that the second normal, and I'm going to use the original surface normal as well. So we get a halfway between the original surface normal and a completely random normal. The next step is to load the, under gradients, tools, and thickness. I'm going to add that and use this random normal as the input for that normal there. We're going to go ahead and give it an index of refraction 1.5 for now, perhaps. Alright, so now after that we just basically have this length is basically the distance that a light ray travels through a surface. Let's see, I believe we want to be double-sided on this. Let me see if I'm double-sided. Yes, I am. Alright. We basically have a plane surface that has a bump map on it, which is a little bit of a dinosaur skin bump map that will be reflected in our shader since we're not adding a bump part of our nodal surface. Alright, so now what do we do with this thickness parameter? Well, let's talk about that. First, we need some kind of surface for our dinosaur to actually be shaded with, so I'm going to use this Lambert shader. For now, it might be better in the future to go ahead and spin our own shader where we can have control over all the shading, the shadows and everything. With the tricks we're doing in this, it may not work with the shadows that come with the Lambert shader. We might want to, for now I've gone ahead and turned off shadow casting for the light, so that'll solve that problem for now. We can always solve that problem later. Alright, so let's go ahead and go into not materials, but shaders, and just use the Lambert shader. It's a very simple lighting model. It's based on the dot product of the vector between the surface normal and the vector towards the light. So if we wanted to create this in on our own, all we'd have to do is take a dot product node and a subtract node. You'd subtract the world light position from the surface, from the object spot, which is also a world position in space, and normalize that, and then take the dot product of that and the surface normal. Alright, that's basically all Lambert does. Lambert, by the way, is the default shading method used in Lightwave. Alright, so for this Lambert shader we need, basically, we don't need much of anything. We just have to plug that into diffuse shading, and you'll see really nothing has changed because, like I said, Lambert shading is the default lighting shading in Lightwave. Alright, so what we need to do is maybe make this a color first of all, and this will be probably our red color. That's going to be the insides of our dinosaur, and we have to combine this somehow with another shader, which will be a green shader. So let me add another version of that, Lambert. Let's see, did I get it? There we go. And I'll make this one green. Alright, so there's that. If I plug this in to the Diffuse shading, our dinosaur should turn green, which it did. Alright, so now somehow we have to combine this with this. The red has to be on the opposite side of the light, and the green has to be the side shaded by the light. So we have to, and then we have to add these two also. So let's see what we can do about that. We need a inverse of the normal so that we can have the unshaded side be lit. Let me use a subtract under math. There should be a subtract vector and we're going to subtract the sorry, we don't want to subtract, we want multiply. It's a little easier to, a little simpler to use multiply instead of subtract. I think you could use both in this case. We're going to take that normal and multiply it by -1 on each axis, x, y, and z. And we're going to take that, that's now a normal, that's been reversed. We're going to plug it into the normal input on our second Lambert shader, the red one. And if all goes well, in fact, if we plug this into our diffuse shading, we should now have a dinosaur that is lit on the opposite side of the light. You can see the light's on the opposite side of the dinosaur, slightly above the dinosaur. Alright, this is behind the dinosaur. We are yet seeing the front side lit. So that shows us that that worked. Now let's add the green and the red together and see what we get. We'll go to, let's see, I was already in math, vector, add. Let's just add the two outputs from the Lambert shaders. Add them together. Whoops. Add them together and plug that into our diffuse shading and see what we got. Well, lo and behold, we now have a dinosaur that is green on the lit side and red on the unlit side, or the side that's letting the translucent light shine through. And that's a pretty big step already in order to do this this subsurface scattering. So in my next tutorial, hopefully I'll pick up where I left off, and we will continue what we've started here. So talk to you later.